Hello everyone. I'm Andy from ThinkMo. I'm teaching CCIE course. As of today, I'll share some with you. Technology related to CCNA, CCNP, and CCIE. Our topic today is IPv6 address representation, structure and classification. First, we covered the following issues. The first point is what is IPv6? Although we did in the last issue. But now we're also going to mention it briefly. IPv6 is a version of the Internet Protocol. It is the next generation IP protocol of IPv4. So IPv4 is very common. Let's say we need 192.168.1.x. All IP addresses are IPv4. We talked about why use IPv6. That's basically because IPv4 addresses are insufficient. The second aspect is that how to represent an IPv6 address. For IPv4 addresses, it is expressed in dotted decimal notation. And of course there are binary representations. It is mainly in dotted decimal notation, or the slash method. So let's see. How do you represent an IPv6 address? First, we need to know about the difference between IPv6 and IPv4 addresses. An IPv4 address is 32 bits long. A bit is a binary bit. It only contains 0 or 1. The maximum length of an IPv6 address is 128 bits. That means it has a range of 128 bits. It is separated by a colon. It is a 32-bit hexadecimal number. We can look at two groups. IPv6 address per group. It's 16 bits in size. There are 8 groups in total. A hexadecimal number separated by a colon. It's just a colon. Divide the 32-bit hexadecimal number. 32 bits is what we call a bit. So there are 16 bits in front of the colon. There are 16 bits after the colon. And the way it's represented is delimited by a colon. The following is a segment of the address. Very long. It's hard to remember. IPv6 has a corresponding compression format. What is a compressed format? We can think of it as shorthand. So here we go. Take a look at the shorthand rule. The first one is mentioned. The leading 0 in each group can be omitted. The leading 0 is the 0 at the beginning of each group. Can be omitted. Let's say this is the address in the picture. The second group has 40. Just abbreviate it to a 0. Let's do another one. That's the group 09C0. The abbreviation is 9C0. Because this 0 in this hexadecimal group, it's the beginning. Let's call that the leading 0. So it's shortened to 9C0. That's the first way to write it. The second is the 2 in a row contained in the address, or multiple groups of all 0, can be replaced by a double colon. The address at the bottom is. It's like taking the old address. Shorten it to the shortest. The shortest is the 40 in this group. It's abbreviated to 0. The 4 zeros in the last two groups. The abbreviation is a double colon. So can I have the first 40? It's abbreviated to a double colon. That's okay too. But in an IPv6 address, only one double colon can appear. This is something to be aware of. So why is there only one double colon? So let's look at this address. We can take a look at the address. If this is 130F, now we have 40. That means 4 groups in a row. They all have 40. These 4 groups can only be replaced by a double colon. There's no problem with that. If the other way around, for example, the last two groups become 80. Let's say this is replaced by a double colon. This is also replaced by a double colon. Same thing in the back. So there's a problem. We don't know the first one. Whether it's 8 zeros or 4 0. I can't derive it. It's possible to put the back. I have 8 zeros in both groups. Let's say it's 4 0. Because 4 0 can also be double colons. So in an IPv6 address, only one double colon can appear. That's a rule. So when we abbreviate, I prefer to put more zeros in a row. It becomes a double colon. This allows for shorter abbreviations. It's not that the first 4 zeros can't work. It's because only one double colon can appear. So pick the one with more. So let's see. Structure of an IPv6 address. Its structure is similar to an IPv4 address. This is preceded by the network prefix. It's the IPv4 equivalent of a network ID. Let's say we write 192.168.1.024. 192.168.1.0. It's a network prefix. Of course, this is an example of IPv4. The next one is the interface ID. Let's say 1.1 is the identity of the interface, an identifier of an interface. So what do we use to distinguish? Which part is the prefix? In IPv4 we use masks. IPv6 also has this concept. Let's write an IPv6 address. 2001-164. PI64 is the first 64 bits. Is a network prefix. That's 128 bits. Minus the 64 bits. I'm only going to have 64 bits left. So those 64 bits are the interface ID. Method of generating the interface ID. There are mainly the following ways. Let's talk a little bit about it. The first is manual configuration. You can manually configure the interface ID. The second type is automatically generated by the system through software. Systems like Windows. It has its own internal private algorithm. By private algorithm, the interface identity is then generated. The next one is the next one. It's called EUI 64-bit conversion. We'll do this conversion later. We'll talk about it accordingly. So this is the stage. It mainly involves these three aspects. It's a manual configuration. And the system is automatically generated by software. And it's EUI 64 specification to generate. So the most commonly used one is specification of EUI 64. Next comes the classification of IPv6 addresses. It's divided into our unicast addresses, multicast address and arbitrary multicast address. First of all, a brief introduction to the unicast address. It is the equivalent of an IPv6 public address. I don't need to talk about the multicast address. Multicast addresses are also known in IPv4. The second is the arbitrary broadcast address. It and the unicast address. It's the same address space. So we can see that. For IPv6 it is. The broadcast address was cancelled. We talked about this in the last video. That means it doesn't have ARP. That's all for today. If there are any other skills you would like to learn, feel free to leave a comment or send me a private message. If you're interested in what I'm talking about, hope to like and subscribe more. Thank you. See you next time.